Alright, 8.3, the number E. The number E. So, here we go. Natural base E, or the Euler number. Okay? It's a number, and it's kind of like pi. If you know pi, pi keeps going on forever. 3.1415926535897993. I could keep going, but the point is, it just never ends. Well, the Euler number is the same way. And that's why they put this little e there, which stands for. They just denote it as the e, and basically, roughly speaking, E stands for about 2.718. Roughly, is about what E stands for. So why would be something like this created is the point. Well, basically, here's what happens. If you remember back in 8.1 when we were talking about compound interest, we had this formula. And this was n standing for the number of times. And the problem is it kept changing, right? If we did it quarterly, I put a 4 in there and there. If we did it monthly, I put a 12 in there and there, right? So we did this already before, but the point is it kept changing. And you would still continue if it was continuously speaking. Notice that the higher we got, the more money we made, but it started to get very little over time. Like we could do 365 days. I could do every minute, every hour, every second if I wanted to. But the closer it gets, instead of saying, what if the interest was calculated every second of the day? It kind of just gets a waste for you to plug in those numbers. So the point is, as it grows, it gets to the same rough estimate of a number, which is E, which is what we're talking about here. So that's basically what E is. So instead of doing that, we put E in its spot. Just some little things to keep on value with E is you can treat E as if it is a variable. So all you're basically going to do here is you're just going to add the exponents. Because they're side by side, all you simply need to do is add the exponents. So 3 and 4 is 7. So you just write and add them together to get E to the 7th. This is the same with division. You would take the 10 and the 5 and divide them to get 2. But then, just like with the exponent rules we talked about in Chapter 6 and in Chapter 7, all I need to do is subtract those. So 3 minus 2 is 1. So we end up with 10 divided by 5, which is 2. And those, when we look at those, that is 3 minus 2 is 1. So it's just e to the first power. So we actually end up with, combining those together, 2e as your answer. With something like this 2 still gets distributed through to both, so it's 3 squared, and it's 2 times negative 4x, so it's 2 times negative 4x, which is negative 8x. So this is actually 3 squared and e to the negative 8x. So that becomes 9, but since we can't have negative exponents, and I'll just move that here. Remember, you can't have negative exponents, so that negative 8x goes on the bottom, so it's e to the 8x on the bottom, and the 9 stays on top. So just something there for you to keep in mind. Alright, so using a calculator, just figure out what e squared is. So where is e on your calculator? So what we need to do here is, let's find out where e is. Do you see ln on your graphing calculator? See where ln is? Well, right above that in blue is an e. That's where e is on your calculator. So you have to press the second key to get to it, and you press ln, and you have an e with a caret sign in parentheses. So in that parentheses, you type a 2 end parentheses in there, and when you get it, you get roughly 7.389056. You can also type in negative negatives as well, so press second ln again, and you just type in negative 0.06 end parentheses, and you would get roughly 0.941765. So really that's all that it was. Nothing big, nothing spectacular, but now let's make sure we can graph these on our calculator. So go to y equals, and if you have something there, just clear it. So it's 2 times, go to second ln, that will give you the e. The caret sign's already there, so we just have to plug in 0.75, type the x afterwards, which is where the alpha sign is, right beside the alpha, and then end parentheses and go to graph. So when you go to graph, it kind of goes up like we saw the exponential ones go up before, right? It kind of goes up in the same fashion. So let's look at our list, go to second graph, and see what our table looks like. And we're going to start at negative 2, and when we plug in a negative 2, we get roughly 0.45. When we plug in a negative 1, we get roughly 0.94. When we plug in a 0, we get 2. When we plug in a 1, we end up with 4.23, and when we plug in a 2, we end up with 8.96. So when I go to graph this, this is saying I go over negative 2 and I go up almost a half and put the point there. I go over negative 1 and I go up almost a whole right there. I go over nothing and up 2 and put the point right there. I go over 1 and up 1, 2, 3, 4.23, which is right there. I go over 2 and I go up 8.96, which is rightfully there, and I connect it with a line. Now keep in mind, like we talked about before in the other sections, where's the asymptote in this problem? Well, the asymptote is a horizontal asymptote at y equals 0 because it gets really, really close to 0, but it never touches. And once again, there's no number hanging out here all by itself. That's where the horizontal asymptote is. So that's just something for you to keep in mind when you're doing this. So there's no number, which means it's 0, so it's y equals 0 is the horizontal asymptote. When we come back here, we're going to graph this problem and finish up with the compound interest because there's a new interest formula that we can use. So when we come back, we'll talk about that and finish up 8.3 on the number E.